Welcome back to the Math Layer. Today's topic, the Rule of 72. And I'm going to show you the mental math shortcut that separates wealthy people from everyone else. Here's what we're covering.
How to instantly calculate how long until your money doubles. Why a tiny 6% difference in returns creates a 15 times wealth gap. The 5 critical limitations. And when this rule completely breaks down.
Plus, we're tackling the dark side, how fast your debt is actually destroying you. And we'll walk through a real scenario with two investors, Alex and Jordan, who invested the same amount, same time, but ended up $592,500 apart.
So if you want to understand the exponential math behind wealth building, stay tuned.
Let's dive in. I was thinking about that old quote about compound interest being the eighth wonder of the world.
The one they always attribute to Einstein, right?
That's the one. But the thing about wonders of the world is you just kind of stare at them. You don't really know how to use them.
That's a really fair point. I mean, we all get the concept, right? Money makes money. But our brains, they're just not built for it.
You're linear.
Totally linear. We think in addition, not multiplication. If I take 30 steps, I'm across the room. Simple. But if I take 30 exponential steps,
where each one is double the last,
I'm a billion meters away. I'm literally circling the planet. And that's the disconnect.
which is how you get blindsided by credit card debt or, why your savings account seems to go absolutely nowhere for a decade.
Exactly. You need a translation layer, something between our linear minds and the way money actually grows. And that's the rule of 72.
So it's not a perfect calculator. It's more of an intuition builder.
It's a skeleton key. It unlocks the one question every investor really cares about. When does my money double?
Okay, before we dive into how it works, I have to ask about the number itself. 72, it feels, I don't know, completely arbitrary. Why not the rule of 100 or 50?
Right. It feels like some old banker superstition.
Is it? Or is there real math here?
Oh, there's definitely math. It's grounded in calculus. Specifically, it comes from the natural logarithm of 2.
Okay, calculus. So you're saying technically it should be the rule of 69.3.
If you want to be perfectly precise for continuous compounding, yes. The natural log of 2 is about 0.693.
But try doing that in your head.
Exactly. Try dividing 69.3 by, say, 7.5% while you're walking into a meeting. It's a nightmare. You can't do it.
So 72 was just chosen because it's friendlier.
Purely for computational simplicity.
Yep.
I mean, think about it. How many numbers divide cleanly into 72?
Well, 1, 2, 3, 4, 6, 8.
9, 12. A ton of them. It just plays nice with almost any interest rate you'll actually see in the real world. It's a trade-off.
So we traded a tiny bit of accuracy for the ability to actually do the math in 3 seconds.
Precisely. It's an interface design choice. And that speed is what lets you assess risk and opportunity on the fly.
All right, let's test that utility. Walk us through the basic mechanism.
It's dead simple. You take the number 72, you divide it by your annual interest rate. That's it. The answer is how many years it takes for your money to double.
Okay, so a standard index fund, historically, let's say it gets about 10%.
Okay, so 72 divided by 10.
7.2.
Yep, your money doubles every 7.2 years.
And what if I'm being more conservative? Sitting in, I don't know, bonds at 6%.
72 divided by 6 is 12.
12 years. Wow. So you just added almost 5 years to the timeline just by dropping a few percentage points.
It makes a huge difference. And it works in reverse, too.
For when you have a specific deadline.
Yeah. Let's say you have a newborn and you absolutely need to double a college fund in 8 years.
Okay.
So you take 72, you divide it by your 8-year deadline, and you get 9. You instantly know you need to find an investment that gets 9% a year. A savings account just won't cut it.
That reverse function is a fantastic BS detector. I saw you flagged a Bollywood movie scene in the notes.
Oh, this is the classic.
Yeah.
The character in the movie, he promises to double an investor's money in just 25 days.
Sounds great. Where do I sign up?
Right. But just apply the rule. 25 days is, about 0.07 of a year? So you take 72, divide it by 0.07.
And you get some insane number.
You'd need an annual interest rate of almost 1,460%.
So unless you're a loan shark in a superhero movie, that's not happening.
Not happening. The rule just cuts through the sales pitch and shows you the raw, impossible math.
I want to apply that raw math to this case study we have, Alex and Jordan, because this is where the numbers get, honestly, a little disturbing.
The tale of two investors. This is where it all clicks. Yeah. So the setup is simple. They both start at age 25.
Both invest $10,000.
And they never add another penny. The only thing that's different is their rate of return.
Okay, so Alex plays it super safe. He gets a 3% return, high yield savings, maybe some government bonds.
And Jordan takes on some standard market risk. gets a 9% return in a diversified portfolio. Now, your linear brain says 9 is 3 times 3, so maybe Jordan ends up with 3 times the money.
Or maybe, 4 or 5 times if you account for the compounding.
Let's run the numbers with the rule. For Alex at 3%, 72 divided by 3 is 24.
A 24-year doubling period. That is agonizingly slow.
It is. If he starts at 25, his money doesn't double to $20,000 until he's 49.
49, and then it doubles again.
To 40,000 when he's 73. So he retires with, around $42,000. He waited almost 50 years to make 30 grand.
Okay, brutal. Now let's do Jordan. 9% return. So 72 divided by 9 is 8.
An 8-year doubling period, which means he gets 3 doubles in the time it takes Alex to get 1.
Let's walk through it.
Sure. At 25, he has 10,000. At 33, 20,000. At 41, 40,000.
Wait, stop there. At age 41, Jordan already has what Alex will have at 73.
He literally bought himself 32 years of time. And he's not even close to done.
Keep going.
At 49, it's 80,000. At 57, 160,000. At 65, 320,000. And by age 73, he has roughly $635,000.
Hold on, 42,000 versus 635,000. That's not 3 times more. That's a 15 times difference.
It's a $592,500 gap, all from a 6% difference in the annual return.
That is life-changing money. That's a house. That's retirement. And the only variable was the velocity of the compounding.
You said it. It shows that time is your greatest asset, but the rate is the accelerator. Alex was on a bicycle. Jordan was in a Ferrari. Same road, same amount of time, totally different destination.
It makes you think that being safe with a low return is actually one of the riskiest things you can do with your future.
And speaking of risk, we have to talk about the flip side. Because the math is neutral. The rule doesn't care if the interest is working for you or against you.
Right. This is the dark side of the rule. Let's talk about credit cards.
The average rate is often around, 18 to 20%. Let's use 18%. It's easy math. 72 divided by 18 is 4.
4 years. So your credit card debt doubles every 4 years.
If you're not paying down the principal, yes, it's reverse compounding. I mean, you're fighting to get maybe a 3% raise at work while your debt is growing at 18% behind your back.
It's like you're running up a down escalator.
An escalator that's moving 6 times faster than you are. You can't win that race. When you carry that balance, you become the source of their compound growth.
And there's another force using this against us. Inflation. We kind of treat it like the weather, but it's really a countdown clock on your money.
It absolutely is. Let's say inflation is at 3%. Apply the rule. 72 divided by 3 is 24.
So in 24 years, the purchasing power of every dollar you have gets cut in half.
Exactly. So that 100 grand you've stashed under the mattress for a rainy day.
In 24 years, it only buys you $50,000 worth of stuff.
And that's at 3%. If inflation jumps to 4%, the halving time drops to just 18 years. This is why the Alex strategy, the safe 3% return, is really a losing game. Your real return is 0.
You're just treading water.
To build any actual wealth, your investment doubling time has to be faster than the inflation halving time. It's a race you have to win.
And this logic, it scales up beyond just us, right? You can apply it to entire countries.
Oh, absolutely. History is often just the story of which country had the better doubling time. You take 2 nations. Nation A is growing its GDP at 2%. Nation B is growing at 3%.
Again, that 1% difference sounds like nothing. A rounding error.
But run the numbers.
Yeah.
Nation A doubles its economy every 36 years. Nation B does it every 24 years. So over a single lifetime, say 72 years, Nation A doubles twice. It's 4 times richer.
And Nation B?
Nation B has doubled 3 times. It's 8 times richer. The gap between being 4 times richer and 8 times richer is everything. It's geopolitical power.
It's amazing that the same math that governs a visa bill also determines the world order. But, okay, we spent a lot of time glorifying this rule. We need to talk about where it breaks down. It's a hack, right? An approximation.
It's a compass, not a GPS. It points you in the right direction, but it doesn't show you the cliff 10 feet ahead.
Yeah.
And yeah, there are some pretty clear limitations.
Let's start with the sweet spot. Where is the rule most accurate?
It's most precise in that 6 to 10% range. At 8%, it's almost perfect. The difference between the rule and the actual math is tiny.
But what about at the extremes? Say I'm looking at a startup that's promising 50% returns.
At that point, the rule starts to fall apart. The approximation drifts. So at 50%, the rule tells you your money doubles in 1.44 years.
And the real math
is closer to 1.7 years. Now, that doesn't sound like a huge gap, But at those high velocities, a few months is a big deal. The further you get from that 8% center, the less you should trust it.
Okay, so that's one limitation. What about real-world friction? The rule assumes a vacuum. No taxes, no fees.
And this is probably the biggest gotcha for most people. In a perfect world, your 9% return doubles your money in 8 years. But in the real world, you might have, say, a 1% fee on your fund,
So your 9% is really an 8% return.
or even 7% if you have an advisor fee. So let's use 7. 72 divided by 7 is roughly 10.3 years.
So a couple of small fees just cost you more than 2 years on your doubling timeline.
Over a lifetime, those fees can cost you an entire doubling period. The rule helps you see the time cost of fees, not just the dollar amount.
I like that framing. Don't ask if a fee is worth $100. Ask if it's worth delaying your financial freedom by 2 years.
That's the right question to ask.
There's one more big variable, volatility. The rule assumes a nice, smooth ride.
Which the market never, ever gives you. It's up 20, down 10. The rule gives you the long-term average, but it completely ignores the turbulence of the journey.
So good for a 30-year plan, not for next year's budget.
Exactly. And one last thing. The rule assumes a lump sum. You invest 10 grand and you let it sit. It doesn't really account for adding new money.
Like dollar cost averaging from your paycheck.
Right. And if you are adding new money regularly,
Yeah.
you're going to beat the rule of 72's prediction. You're constantly adding more fuel to the fire.
That's actually some good news for once.
It's very good news. For most active savers, the rule is a conservative baseline.
So we've covered the what, the why, the how, and the when not to. How do we bring this all together? If there's one core idea to take away from this, what is it?
I think it's to stop obsessing over the account balance and start obsessing over doubling periods. Focus on the frequency of the double.
Because the last double is always worth more than all the previous doubles combined.
That's the mind-bending nature of exponential growth. You know the folding paper analogy. Fold it 42 times, it reaches the moon. But at fold 41, it's only halfway there.
That final fold does all the work.
It equals all the work that came before it. It's the same with your money. That final double, maybe between age 60 and 68, that's where the vast majority of your wealth is actually created.
Which I think brings us to our final provocative thought for today.
Right. I want you, the listener, to do a quick calculation. Think about your doubling clock. How many years do you have between today and when you want to stop working?
And then look at your investments. What's your doubling speed?
Exactly.
Yeah.
If you have, say, 20 years left to work and your money doubles every 10 years, you have 2 doubles left. That's it. Just 2.
That's a lot fewer than I think most people would imagine.
It almost always is. So the question becomes, what can you do right now? Cut a fee, increase your savings rate, reallocate something to try and squeeze in just one more doubling period before the clock runs out.
Because that one extra double changes the entire outcome.
It literally doubles your life's work.
A very powerful place to leave it. Stop counting the dollars and start counting the doubles.
Couldn't have said it better myself.
Thanks for joining us on The Math Layer. We'll catch you on the next deep dive.
See you then.